Okay, so we're here for the second part of our lesson in section 6.2, and we are looking at factoring trinomials of the form x squared, x squared plus bx plus c. But now, in this particular case, we're going to look at when the value of c is negative, and we're going to take a look at the impact that will have on factoring trinomials. These are typically the problems that students have the most difficulty with, even with an a coefficient of 1. So let's go ahead and begin with some basic problems in this. We're going to consider problem 15 from the textbook to first help us out. That'll be x squared minus 2x minus 15. As we've done before, we're going to identify the values of a, b, and c. Some of you may be able to do this from the formula here, but for the purpose of the review, we're going to keep identifying these at least in this section on the side. So the value of a is going to equal 1. The value of b will be negative 2. But now the value of c is going to be negative 15. And we need to consider how that's going to impact the type of factors we're going to get. So when we go to the side here, and we look at a times c, and we look at b, we have positive 1 times negative 15 giving us negative 15, and then the value of b being equal to negative 2. Well, the only way we can get a negative product is by multiplying a positive number and a negative number. So we're going to have one positive number and one negative number. So in this instance, we know that we're going to have a positive number or a negative number, but which one has to be positive and which one has to be negative. So let's look at all the ways that we can get a product of negative 15. So we can do negative 1 times positive 15. However, we can also switch the signs of these and write these as 1 times negative 15. So we are multiplying the same pair of numbers, but then we switch the signs of those numbers, which will still give us a product of negative 15. Most of you also recognize that we can have negative 3 times positive 5, but we can also have positive 3 times negative 5. All of these combinations will give us a product of negative 15. What we need are the pair of numbers that is going to yield a sum or difference of negative 2. So if I were to, for example, add these together, negative 1 plus 15, or 15 minus 1, well, that'll be 14. 1 plus negative 15 will give me negative 14. Well, those don't give us the results we're looking for. Let's now look at negative 3 plus 5, or negative 3 plus a positive 5. Well, negative 3 plus a positive 5, that's going to give me plus 2. Well, that's close. Right number, wrong sign. So let's go here. 3 plus a negative 5, that is what gives us our negative 2. So here we need a positive 3, and we need a negative 5. So we're going to take these two numbers now. We're going to write x squared as x times x, and now we're going to take the numbers plus 3 and negative 5, and we're going to put these into the trinomial factors. So the big change when the value of c is negative is this. Instead of adding the two numbers up and getting the sum of the numbers, we add the numbers up, but we're really now comparing the difference of the two numbers. So what we are looking at for these here is now we are looking at the difference of the numbers. We still add them up, but we're looking at the difference that exists between the numbers because the numbers are opposite signs. So I know this may sound a little confusing, but for those who are okay with their basic integer skills, hopefully this is not too treacherous territory for you. So let's keep going forward and doing a few more examples of this here. Let's take a look at one that's going to have quite a few factors here because these are problems that often trip up many students. We're going to go ahead and take a look at question 16. X squared minus x minus 42. And again, let's go ahead and identify the values of a, b, and c. A is equal to 1, b is equal to negative 1, c is equal to negative 42. So let's go ahead and make our x box here. Let's take a look at the values of a times c, and then take a look at the values of b. We know that 1 times negative 42 will be negative 42. b is going to equal negative 1. So we're looking for two numbers who multiply to negative 42, but that add to negative 1. Well, the only way we can get a negative product is by multiplying two numbers whose signs are opposite. So we know that, but we don't know what numbers those are yet, nor do we know the sign of those numbers. So let's take a look at all the way to get negative 42. Now, just word to the wise in this. We know that the difference of the numbers has to be negative 1, so it probably isn't necessary to go with like negative 1 times 42 or 1 times negative 42. Obviously, because these numbers are far apart, their difference is also going to be large. Now, I'm saying this right now. Nonetheless, to reinforce this technique, I'm going to continue to write down all the possible factors anyway to reinforce this. Okay, so now we have negative 2 times 21, and we have 2 times negative 21. We have negative 3 times 14. We have 3 times negative 14. We have, and for the last one here, we have negative 6 times 7, and then we have 6 times negative 7. So all of these. So obviously, the larger the difference between the numbers, the larger the difference will be overall. But we want something closer to 1 or negative 1. So I think that's more likely going to be down here. If we take negative 6 and add that to 7, the difference will be positive 1. Right number, but wrong sign. So if we look at 6 plus a negative 7, that's the combination that gives us the difference of negative 1. So I'm going to write this as plus 6 and minus 7. And we're going to go ahead and put those as our two binomial factors here to write this as x plus 6 and x minus 7. So now we have our pair of binomial factors for x squared minus x minus 42. We're going to take a look at a few other problems to reinforce this skill. Let's take a look at the problem now. Let's see, this is 25. We have the problem written this way. 3x plus x squared minus 10. So two things that could potentially trip you up in this question. When you go to identify A, B, and C, students who are not really thinking about this question may go ahead and say A is equal to 3, B is equal to 1, and C is equal to negative 10. However, the problem with this is that this trinomial is not written in the form that we discussed when we began this in the beginning of the video lessons. So it has to be written in the form of x squared plus bx plus c. So what I have to do first to correctly identify the values of a, b, and c are to write it in this form, which essentially means I need to do kind of a yin-yang operation here and switch these two terms around to write this now as x squared plus 3x minus 10. So, well, I really didn't need to cross out c because that's still negative 10. But the value of b is now going to be considered equal to 3, and the value of a is going to be 1, which is what we're looking for in the first place. What's different about this example for this lesson is, even though we have a negative value of c, we now have a positive value for b. So let's take a look at how that impacts our results. So again, we have a times c here. We have b. We're going to multiply here, add here. So 1 times negative 10 will be negative 10. And here we'll have a sum of 3. So we're looking for two numbers that have a product of negative 10, but have a sum of 3. Again, the only way to get a negative product is to multiply a positive times a negative number. But now we want the difference of these numbers to be a positive difference. So let's consider all the ways to get negative 10. we have negative 1 times 10, and we have 1 times negative 10. These are going to have a difference of 9, negative 9. That's not likely. So we have negative 2 times 5, and then 2 times negative 5. Well, negative 2, well, these have a difference of 3, so that looks more promising. So let's look at what their sums are. Negative 2 plus 5, if I add these, that does give us a difference of positive 3. This is the difference we're looking for, so we can conclude that the 2 that is negative and the 5 that is positive must be the pair of numbers that are going to go into the binomial factors. So now we can take these two numbers and write these as x plus 5 times x minus 2. And now we have our pair of binomial factors. We're going to go ahead and do one more question related to this, and then we're going to offer a few more trinomials to factor that will have some additional tricks thrown into the mix. So let's take a look now at question I'm going to modify the question 21 a little bit, but I will come back to it in its original form later. So this is going to be a squared minus a minus 72. I'm going to go ahead and make it plus a. So I want the value of b to be positive here. So again, when we talk about a, b, and c, we're not talking about the value of a that comes from the variable that is squared and is here. We're talking about the a coefficient that should be here, which in this case is 1 again. The value of b is also equal to 1, but the value of c now is negative 72. So we're going to gather our information in our x box again. A times c, and then b. Notice here I'm going through this a little faster because after you're watching the video you should have some fluency with it. And please again feel comfortable to stop the video so that you can keep up comfortably. And if you want to, you may also simply just want to watch the video once before taking all this down if you think that would help, before taking any notes. So we have a product of negative 72 and we have a sum of 1. If it helps, go ahead and put a positive there. Now, there are a lot of ways to multiply a pair of numbers to get 72. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. Not to mention, because the signs of these two numbers are going to be different, that you could write each of those in two different combinations. There are a lot of combinations here. However, because we only have a difference of 1, we don't want numbers like 1 and 72 or 2 and 36. We want pairs of combinations whose numbers are very close together. So for negative 72, I'm just going to write down a couple. Negative 6 times 12, 6 times negative 12, and then I'm going to go ahead and write down 8 times, or negative 8 times 9, and then 8 times negative 9. So if I add these together, negative 8 times 9 will give me a difference of 1. Since this is the sum I'm looking for, I would write this as plus 9 and negative 8. And these are the pair of numbers that are going to go into my binomial factors, namely a plus 9 and a minus 8. And now these are the pair of binomial factors that represent the trinomial above. Next, we're going to take a look at factoring trinomials that won't have an a coefficient of 1 to begin with, but will require factoring out the greatest common factor as a first step to get the a coefficient equal to 1 so that we can factor them in the same manner we're doing here.